In the previous demo, we implemented a simple querying collection framework, and now we are going to extend it in order to support projection. So we would like to be able to select a list of properties, and we will also implement ordering by different criteria and a way to filter with numeric values like numeric value comparators. Basically, we will start with what we did previously. And first of all, I would like to be able in here to implement, let's say, numeric comparators. That's easy. So what I would like to do with where, as you can see here, we are expressing a query condition in order to filter. So in here, we are collecting query conditions by using a field in the model, a wrapper on top of the field. So we implemented a like condition and would like to be able to check also different type of conditions. So first of all, we have a query condition types, which is an enum that we can use to specify the type of the condition. So we would like to be able to have comparators like less than or equals, okay, equals to, also not equals to, sorry, equals to, and also greater or equals to, and of course greater than. Okay, so basically with this, when we define a condition, we can specify the type of the condition in the query field. Okay, so in the query field, I will add new type of conditions that can be defined, like for instance, less than, sorry, wrong case, less than, this is less than. Okay, another type of condition, less than or equals to, less than or equals to, which should be of type equals to, greater than or equals to, of type greater than or equals to, and of course we missed one, not equals to, but let's define greater than first. Okay, greater than, and I will define in here not equals to, of type not equals to. Okay, so with this I can specify, if I go back to my test, I can try to select all the cities which has a name starting with B, and I would like that the number of inhabitants, so I will use the field inhabitants, to be greater than or equals to, and I will use, let's say, in this case 30,000, which is not a great number for cities in Romania, but there are not many cities starting with B. So first of all, I would like to actually check these conditions. So I will go, if you see here, we are returning a new query condition, and in here, when we are checking the item, we are just checking the like operator. Okay, so what I would like to do here, I will try to see if the value is a comparable of the type V, and I will define a comparable of type V, comparable value, and if value is an instance of comparable of type V, then I will return the cast to comparable of type V from the value, otherwise I will return null. Okay, so that's that's my value, which should be an instance of comparable in general. Okay, and now I can say that this should be cast, and my mistake was in here. Okay, so I can still use the generic type, but I would say that I don't want to enforce the checking on generic types. So now that I have tried to cast my value to comparable of V, I will use the rest of operators, and I can say case less than. In case we should compare to less than and value is comparable, then since it's comparable, I can try to compare to this value, which is the reference, and since I expect that the value should be less than this one, the difference should be less than 0, but I still have to check that comparable is not null, otherwise I will get a null pointer exception, and that's because I'm not implementing the value is not comparable. Okay, the second one, less than or equals to, I will use this one and just copy and paste. The value should not be null, but should be less or equal to 0. Okay, the next one, I'll try to see if the value is equals to, and in this case the difference should be 0. Okay, as for not equals to, I will return in the same way that the difference should be not 0. Sorry for that. I'm trying to check if the value is greater or equals to, and I'm returning, in this case, the difference should be greater or equals to 0, and in case I'm checking to be the value should be greater than, I just check that the difference it is greater than 0. The default should be false, so I would say default, in this case return false, so the condition is not verified by the operator. So in my case, what I'm doing is just trying to see if my value is comparable, and if so, depending on the operator, on the type of the comparison, I will try to see if it is comparable and ask it to compare with the expected value. So by doing so, I will be able to filter cities starting with B, and that has at least 30,000 inhabitants. And now when I'm running it, I see the list of my cities, which is reduced. So what I can check in here, I can go to each city, and beside the fact that I'm trying to see if the name starts with B, I will try to say assert true that the result get inhabitants, it is greater or equals to this value. So this should be true, and when I'm running it, I can see that the test pass. Okay, so I also output I'm outputting the name of the city, but that's not necessary to check the test. So if I would say that the value should be less than this one, then my test will fail as you expect. Okay, so it fails because of this one. It says that we have an assertion error in here, and because I didn't provide the message for that, I don't have the details, but normally we should give a message here as a parameter. Okay, so that's all about defining and adding new comparison operators for numeric values. I would also like to be able to filter and do a projection. So I'm not just waiting to get a list of my model, but I would like to be able to select some fields of my model. So for that will be our projection from the model. What I would like to have is define a select method instead of using the list. There is no method defined here, so I will just create it in my query class. And in here, I would like to have a query field of type M and generic value, and those will be my fields that will be used as a projection. I won't return a list of city because there is no static type defined that contains all my fields, and there is no way I can define it statically. Therefore, I will create a query results of type M, which will hold the result. And now I'm just defining it, and I will say that the generic type should be of name M. Okay, so what I'm expecting here, I will save the class, and when I go back to my test, as you can see, I'm supposed to have an error here because my method is not returning a list of cities, so rather that it's returning a query result of type city. So I will get query result of city, and those will be the results. So I will just delete this, and I will try to okay, so I'll try to do a selection. So I try to select based on some criteria, and I can say I would like to see the name of the city, and why not, I would like to see from my model the number of inhabitants, because I would expect to check those values since I'm filtering on it. Okay, so first of all, when I'm doing a selection, what should happen? Actually, I will try to enforce the same conditions that I am doing when I'm listing the values. So what does it mean is that I'm listing the values, but I will have to add each item at the time in a list. So I'll create a list that will be indexed, that will contain actually a map. The map will use as a key the query field of type M and generic, and the value will be an object. So this will be the results. Okay, the map is not imported, so I'll have to import it from Java util. The results I'm creating will be an array list, and I will just copy the parameters from here. So what I'm saying with this is that actually my structure for the results would be as follows. I will have a list with all the items that are matching the conditions, and each item will be actually a map, and I will use as the key the name of the field, and the value will be the value of the field for that item. So this is like a key value pair indexed by the name of the field, and there is a list with all the items for that. In the end, I will have to create this kind of information, this kind of structure, using the results. So I will return a new query results of type M, which is the model, providing the elements that I collected and the structure, the list of fields. I will create this constructor. Those will be the results, and these are my fields. So based on that, what I'm doing here is that I will store the list of results that I got and also the list of fields that were provided by the constructor. So I'm defining these, okay, and by that now I am able, in order to consume the results, I'm able to implement methods such as, if I want to see the number of results, the total lines, the number of lines, I will return dot size, and I can do some getters for the values, like for instance, if I want to get a generic value of type V from a field, that's called the getter get value. I will provide the row index, and also I will provide the query field. And what I'm doing here, first of all, it is better to test against your data. So for instance, if row index is greater, it is less than 0, or row index is greater or equal to results dot size, in order not to get an array index out of bounds, I will return null. It makes no sense to check it. Okay. Second, what I'm trying to do is to get the item, and I will just return the item. The item will be a map having as key query fields and generic object value. So I will get the item from the results with this index. Okay? And if the item is null, then I will return null. Otherwise, I will get and cast to V type the value indexed in item by that field. I also have to check that the field is not null in here. So if the field is null, or the index does not belong to the interval inside the results, then I will return null. I know what I'm returning, so I'll suppress uncheck casting here. Okay, if I'd like to iterate through all the fields, I will need, first of all, a method to return the fields. So I will have a method that will return my model. So I would say here that I have something like a public query field of type M and any, a list of fields, a method called getFields. Okay, so what I'm trying to do here is returning a new query fields array of generic type M and object with the size of the fields. Actually, what I'll do here, it will be to copy the fields by casting it. Fields, it's just a second. Field is just an array, so okay, there is no need to do that. I can just return the fields. I was thinking that I have a list here and I need to convert it to a static array, but that's not the case. Okay, so I'm getting the list of the fields, and now I can implement another method to provide the value of an attribute in a row. So I'll have a parameter, the row index, and the other parameter will be field index. Okay, so what I'm doing here, I'm also checking if row index is greater or equal to 0 and row index is less than results.size, but also I will have to check if field index is less or equal to 0 and also field index it is less than fields.length, and in this case I can return get value of row index and fields of field index. Okay, and this method here, it's expecting a field of v, and I will have to convert it from field of object to query field of type m and the expected value v, and otherwise I will return null, and also I will suppress unchecked warnings. Okay, so now I'm able to consume the results, and I will go back to my test, and in here I'm checking that the results are not null. I will iterate with a numeric index with I from 0 to results count, and for each I will get my item, but the item is not of type city, so I will have to iterate through all the fields that I have, but I know that I have name and inhabitants, and I will just check. Of course I can go and say results get value of row index and field index, but I don't want to do it. I'm just testing, I'm just checking with assert true, that I don't have assert true. Let me check it. It is imported, but I will have to give the arguments. So assert true. I will test first. I will get the value of the model. From the model, I will get the value of the name. So this will be a string name, and I can say results get value with I as row index, and the field will be model name. This will return a string, and I'm checking that name. First of all, I will say assert not null of name, and then I will check that name starts with B, and I will do to lowercase, otherwise it won't start with it is starting with a capital letter. I'll do the same with the number of inhabitants. I will get the value of the field inhabitants with results get value of index I and the field inhabitants, and now I can assert that it's not null with inhabitants, and I will also assert true that the number of inhabitants it is greater or equals to 30,000. Okay, and now when I'm running the test, as you expect, the test passes. If I would change here the operator and I will run the test again, I will see that there is a problem with the value that it is filtered. So let me check it and see what's the problem. I would expect not to get this condition should not be true. So let me check it. First of all, I'll have to see what I'm executing when doing the select. Okay, so of course the problem is that I'm not adding any result. Okay, so I was focusing on defining the data structure and not actually implementing the functionality, but that's not something difficult to do. So what I'm doing here would be, I will go through all my model items that are returned by the list method, and the list method will return actually a list of items. So this is saying that it might throw a query exception, so this method will eventually, it might throw this exception as well. So what I'm doing when collecting the results, I will need for each item to create a map of query field of type M and generic value, but this time I will have to instantiate it, so this should be an object, and this will be a result item. I will call it result, simply result. I'm creating a new hash table, and with this table I will go through all the fields that should be selected. So I will have for each query field of type M and generic for the value in fields. Okay, so in here I will get the value as an object of my field by invoking field get value of item, and with this value I will index it by putting in my map index by the field. So now when I'm visiting all the attributes, all the fields in my model, I'm collecting the information for the row, but in the end I will have to add that to my list of results. Okay, so now if I go back here and I still have the wrong condition checked, and now I run the test, I will see that the test fails because the condition is not matched. If I try to put it the right way as I'm expecting to be here and run the test again, I will see that the test passes this time because now we are collecting the right results. Okay, so what we did so far was to add some numeric operators for the values, but also to do a projection and implementing a way to select a set of fields and not all the items. So now we are getting the results of this kind of information, but with less fields, the one that are selected in here. There is no way up to now to order based on some criteria the results, so we would like to have it. So we'd like to be able to say in here, just order by these fields. I will have to create a method order by. It won't return an object, but instead it will return a query of type M. So it will return this in the first place. Now that's okay, because we are able to compile this. So when we are doing the ordering, we would like to be able to express a list of fields, but it's not the field itself, but also the direction in which we want to sort. So the order by will get an arbitrary number of directions upon fields in which we want to sort. So we will use a new object, let's call it query order, of type M and any. This will be our orders. The type is not defined, we will create it. We'll create in the source folder with M for the type of the model and V for the type of the value. So now we are defining the orders, and all we have to do, we'll have to have a list of orders, and we will add all those orders, and with arrays as list we got a list from our orders. This is not defined, let's do it right now. And if we go to definition of orders, Okay, that's a real problem because we didn't expect to get this kind of field. So the orders should not be a string, but that's a problem with the IDE. So I will just use a list of query orders of type M and any for the value. Those would be my orders. And when I'm creating this in here, I will create a new array list of query orders of type M and any for the value. Okay, so now I'm able to load the order list, and I will suppress some warnings in here as well as in here. Okay, that's just the way we define the orders. We also need a way to specify the orders when we use it. We started with this method, but now I would like to be able to say, let's sort it ascending on the name. I will create this method, and this method, because we know the type of the field, this can actually return an order of type M and V. So we will create a new query order of type M and V, and the order will need two information. First of all, we will need to be able to pass a reference to the field itself, because it will use the field to get the value and do the comparison. So we'll pass the field. And secondly, we will need a query order types enum, which will have the directions in which we want to sort, like ascending. I have to create this first, and I will create an enum. Okay, I will have to create the literal as well in here, and of course I will pass the second value, second direction, descending. Okay, so with this, now I can go back to my method and create the appropriate constructor. So this will be the field, and this will be the direction. And what I want to do here, I will just put the field, I will initialize the object, and of course I will initialize the direction as well. So now in here I'm able to create this field. Okay, so when I use it, I just simply say order by model.name.ascending, but I will also need to have the second direction defined, descending. And I will use the second direction type. Okay, now we are able to collect these, but still we are not applying the ordering. For that, we will have to go to our selecting methods, but not only to the select, which is a projection, but rather to the base one that's doing the listing, the enforcing of the way we are consuming the collection. So we have to go here. So in our query, in the list method, what we do here, we are collecting all the items that are valid to be added to the results, the one that are matching the conditions by checking them. In the end, before returning the results, we would like to use the collections.sort method, and this will sort the results using a query order comparator. This should be of type M and object for the value, and we will pass the orders that we have in our class. So we will have to create this. It has two parameters, one for the type of the elements in the collection, the other for the values, and this comparator will have to implement a comparator, not comparable but comparator, sorry. We'll have to implement a comparator of v for the value. So in here we will have to define the unimplemented method, which will be compare, sorry, not of type v, but of type m. We are comparing the items, and we will compare by all the fields, so not just one value. And this method compare will be of type m, which is the item, and the next one, which will be the compared item in the model. Okay? Of course, we don't have the appropriate constructor that it is used here, so we will create it. Sorry. With this, we are just storing the orders, so I will just create a field with the same name and store the values. And now I can create the field. And when I'm comparing the values, what I would like to do here will be to iterate through all the conditions in the same order that they were defined. And if a condition says that the values are equals, then we will continue comparing them with the next criterion. Otherwise, it makes no sense to continue because they are not the same, they don't have the same value. So what we will do here, we'll go through all the query orders of type M and object that we got. Okay. Actually, they are not of type object, they are of type any. So those will be our orders to sort on. We will get the direction first, the direction of the order. So let's get it like the direction, and this will be if the query order type ascending is equal to the order get type, then we will return +1, otherwise we will return -1. This method is not defined, we will have to do it. So we'll have to return the enum value, and we are just returning the type. Okay? So in here, sorry, that's the ternary operator. Based on the direction, we will compute the result, the numeric result of the compare value, of the compare method. So what we have to do here is get actually the value of the object. So we will call order get field, and this method should be declared as well. We will return the field used by the order, so we'll return the field. This is not a type, it is not called type, it's called direction, sorry. And I will rename the method to be get direction. I'm thinking that we are saying as we do for the where conditions. Okay, I will rename it manually. So get direction. Okay. So I can go now and continue what we are doing here. Okay. So we will get the value of the item by calling order get field get value. This can throw an exception. So in case we are getting an exception and we are not able to throw it because compare method is defined without any exception, we will try to surround with this with a try catch block, and in case we are not able to compare it, we will return 0. Okay, we should get also the compared value, sorry for that, compared value, in the same way by getting with the field the value of the compared object, compared item. Okay, so now what we are trying to do is to get the result of the comparison by calling compare items with the value of the item, the compared item, and the direction. We will create this method in here, and if the result is different than 0, then we will return the result. Otherwise, after checking all the conditions, we will return 0, because by all the criteria the items are equals. Okay, so what we are doing here, we are checking if the values are comparable, and if so, we are going to return the result of their comparison. So we will return that the check that value is instance of comparable of v. We are in a class with a parameter for the value, and of course that the compared value, the compared item, the value and compared item are not correctly used. We're supposed to use here the compared value, sorry for that. So this should be of type object and will be the compared value. So if the compared value, it is the same type, comparable of type comparable of type v, then we will have to return the result of comparing them. So we'll cast to comparable of v the type value, and we will call it to compare to compared value, and we will multiply with the direction. Otherwise we will return 0, since we are not able to compare them. Okay, so this should be instance of comparable. Okay, so in here we will use comparable of any, because we are using object here, and we will ask this to be actually a comparable of object, or even without the generic type. We will cast this to comparable, and we will try to compare it with the given value. Okay, so this is the way we are comparing them. If the value is instance of comparable, then we call the compare to of the type of the value to check the relation to the compared value with respect to the value. Okay, so now what we will do here, if we go back to the method, when we are calling this, the problem in here is that we imported the collections from a wrong package. So this one should be from Java util. Okay. So now if we go back to our test and we just output, we were sorting based on the name ascending, so we just output the model.name just to see it first. Now when we run it as a JUnit test, okay, we are outputting, sorry, not the model.name, that's obviously that's nonsense, and we just wanted to have the name of each item. So the model get name is actually the results get value of the field model get name. So now I should use the name here, okay? And when I run it, I can see that the values are sorted alphabetically. Okay.